Okay, Year 12, some students have asked about some of the questions from here, in particular questions 10 and 11. So I'm going to quickly have a go at these. Remember, when you're doing these, it's good to make sure that you write all the information that you have. So if I'm looking at question number 10, and what do we got here? The common ratio of a series, so R equals 4. And the sum of the first 5 terms, S of 5, equals 3069. Find the first term. Well, we know that S of n equals a 1 minus r to the n over 1 minus r. I could use the other formula, and I probably should because my r is greater than 1, so I probably should use a r to the n minus 1, r minus 1. It wouldn't really matter, I don't think. Sometimes it can make a difference, but I don't think it would in this case. I will use the second one. I'll try to adhere to the way that the book says. So we've got 3069 equals A, which is what we've got to find. And we're going to get 4 to the 5 minus 1 over 4 minus 1. Now, this is just going to be a number. This is as simple as 10 equals 5a. We're just going to divide by the 5 and we're going to get 2 equals a. That's as simple as this is. This whole thing in the brackets here that I've just put, the purple brackets, that's just a number. So what I'm going to do is I'm now going to go, 3069 divided by 4 to the 5 minus 1 over 4 minus 1. That should give me A. So we'll pull our calculator out and we'll go 3069 divided by, let's have some parentheses here and let's put it in as a fraction. 4 to the power of 5 minus 1. Let's go downstairs over 4 minus 1. Those are brackets. We get 9, and that's the answer. Now you could have used the other formula, I'm pretty sure, because you still, this bit here, this A times this would have just been a number. It would have just been the same number. Let's actually double check. We'll try our calculator again. So all we have to do is go back into that and make that 1 minus 4 and go upstairs and make that 1 minus 4 to the 5. And look at that, exactly the same answer. So it wouldn't have mattered which formula you used as long as you just typed it in correctly. Number 11. So with number 11, find the number of terms needed to be added for the sum to exceed 1 million in that series. Well, let's write what we've got. First of all, we've got A equals 4, and the common ratio, 16 divided by 4 is 4, and we have to find n. But we know that S of n needs to be greater than 1 million. Well, let's just find when S of n equals 1 million. So over here, again, I should use the second formula, and I will. So I'm going to get 1 million equals A, so 4, R to the, 4 to the n minus 1 over 4 minus 1. And now this is going to be a little bit harder because we're going to have to use logs. So we've got 4 to the n minus 1 over 3. Well, I'm going to take that million, I'm going to divide by 4 and times by 3. So 1 million divided by 4 times by 3, 750,000. So 750, 1, 2, 3, equals 4 to the n minus 1. Now remember what I just did, I divided by the 4 and I times by the 3. Right, to get that 750. Now I add the 1 over, 750,001 equals 4 to the n. Now this is not going to come out as a neat answer because it's not going to be a definite integer that equals 1,000, and we'll just need the next one up. So what am I going to use now? I'm going to use this, y equals a to the x, and x equals log to the base a y. So I'm going to change the base. Now, other classes and other books will tell you to take the log of both sides. You can do that. And in most cases, it's probably much easier. So I might do that in a minute after I do this one. So I'm going to get n equals log base 4, 750,001. And then I decide what log I want to use because I can use any log base. I'm going to take ln 750,001 over ln of 4. Go to my calculator and ln 750,001 divided by ln 4. And I get 9.75, and we knew it was going to be 9.758. N equals 9.758 ... That's when it hits a million. We need the first number, I'm pretty sure, to exceed a million. Yep, so it's going to come after 9, therefore n that we need will be 10. All right, and if I'd written this in, so I'd like to put it equals to, but you could have just done all this and you could have had greater than, because you haven't done anything. So n has to be greater than 9.754 and it equals 10. Now let's just take this point here where we get to this stage, and I'll show you that alternate method. So you got, let's just make it equal to make it easier in your mind, because people get a bit worried about greater than or equal signs, but you don't have to. 4 to the n. You can take the log, any log of both sides. So the easiest log to take, because taking the log is just an operation. So you're going to ln 750,001 equals ln of 4 to the n. You've just taken the log of both sides. And then you've got to realize that this n can come down the front. So you get ln 750,001 equals, and that 4 comes out the front, and you get ln of 4. And then you realize that ln of 4 is just a number. All right, oh, sorry, I wrote 4 to n. That n comes down the front. And then you divide by that ln of 4. So you get ln 750,001 over ln 4 equals n. The end result is the same. See, it's just the same. But a lot of people find this method a lot easier to do. You just take the log. It doesn't matter what log. You could have taken log to the base 10. You can take log any base. I'll just take ln because it's less writing. Whereas this method is a little more conceptual. You've got to know this rule. Either way is acceptable. Just make sure you are consistent in whatever way you like to use. All right, good luck.